Disclaimer. This video tutorial is for training and information purposes only. The techniques and recommendations presented in this video are based on general best practices and experience. Please note that individual circumstances, such as specific company policies or industry-specific requirements, cannot be addressed in detail. The information contained in the video is not a guarantee of success in the subject matter and does not replace the need for individual preparation and practice. The content reflects the opinions and experience of the creator and makes no claim to completeness or accuracy in all situations. The creator accepts no liability for any direct or indirect loss, damage or inconvenience that may arise from the application of the content presented in the video. For detailed advice or special requests, please contact us at contact@experts4excellence.com. All content shown in this video is protected by copyright. Any reproduction or distribution is only permitted with our written authorization. Welcome to the course Basics of Lean Management. This is part 3 of this module. In part 3 of this training we will learn how the principles of lean management are applied to manufacturing processes. Let's look at the traditional series production first. In a classic flow production, the individual workstations are arranged one after the other exactly as they correspond to the logical production steps. Often, the individual work contents are reduced to minimal activities, so that each individual step requires only a few seconds or minutes. This makes it easy to create a TOCT. The advantages of this system include straightforward planning, simple clock synchronization, good for high-volume productions with few variants, also known as high-volume low mix, ideal for transport automation, conveyor belt. The disadvantages are highly tailoristic, low flexibility, fast fatigue due to simple work contents, high susceptibility to errors, tendency towards high employee fluctuation. As an advantage and disadvantage at the same time can be seen the low need for qualification of employees. The disadvantage, and this outweighs the advantage, is the boring and always same activity. This causes employees to tire quickly and increases their susceptibility to errors. The photo shows a typical flow production in a Chinese factory. A very powerful alternative to the serial manufacturing line is the U-cell. U-cell can be designed as 3, 5 or 7 station cells that are arranged in U-shape. These cells can be operated by a flexible number of people, depending on the workload and availability of workers. For example, can a 3-cell be operated by only one person going with the process flow from station to station, or it can be manned with 3 people, one for each workstation. Accordingly, a 5-cell can be manned with up to 5 people if necessary and possible, or with any lower number, requiring the people to operate more than just one cell. This is shown in the 7-cell depiction. Here are the benefits of U-cell manufacturing. Variable design of the cells 357. Thereby high process variability. Thereby high product variability. Cell composition product-oriented or process-oriented. Employee deployment highly flexible. It can thus be adapted to production volumes. Prerequisite, more highly qualified employees. High job satisfaction through diverse activities. Easy filling of the workstations with consumables from outside by milkmen. Can be integrated into a line concept. Ideal support of the lean concept. Ideal for high mix, low vol productions. The milk run and the supermarket models are perfect methodical additions to U-cells and serial productions. Using these methods, standardized small parts with regular and high consumption, such as screws, nuts, washers, gaskets, etc., are fed into the production line. In the milk run model by dedicated employees, in the supermarket model by the line employees themselves. Often the milk run is filled according to the Kanban principle. Prerequisite, high degree of standardization, Jidoka. In the milk run case, a dedicated person does nothing else than filling up the workstations with standard material. In the supermarket case, the workers themselves fill up standard materials from a nearby supermarket shelf. Now stop the video for a moment and sit back to think about where you could apply a U-cell principle at your home. Once you've found something, continue the video. Here is an example. The setup of your kitchen. How could this look like? Lean management includes a number of very useful tools and methodologies that support the philosophy. Very often, these are described by abbreviations. We want to have a look at the most common and powerful ones. Let's start with the 3M and the 7+1 kinds of waste. 3M stands for Muri, Mura and Muda, and those are negative things that need to be avoided in the lean methodology. Muri is the overload, mostly the overload of team members due to work. Mura is the imbalance of work, meaning the unequal distribution of the workload. Muda describes activities that do not create value. This raises the question, what is value? How would you define value? Spend a moment on this question. We will come back to it later. Now, let's look at the non-value adding elements. These can be described with the 7+1 wastes. Defects, expenses due to reworking, scrapping, replacement, etc. Overproduction, just-in-case production. Waiting time between two processes due to missing leveling. Transportation, unnecessary transport routes in production and between productions. Inventory, excess stocks of raw materials, semi-finished and finished products. Motion, unnecessary movements by employees. Extra processing, additional costs for production or quality not required by the customer. And the +1 kind of waste is talent, meaning your people and their knowledge, that you do not utilize. If you now read the first characters of the 7+1 wastes from top to bottom, you will get the word downtime. This is a little thought support to memorize the 7+1 Ws. Now let's come back to the question, how value is defined. A simple but powerful definition is: value is everything the customer is willing to pay for. Now let's have a look at the 7+1 kinds of waste in detail. The first one is defects. Whenever production is not focused on quality, defective products are created. The photo shows this very clearly. All containers with a red label contain defective products. These have to be excluded from production and put into quarantine to be further examined or repaired. This is more work that has to be paid for. It is almost always poor or faulty processes that lead to increased scrap. In the picture on the right, we see how the setting of a machine affects the result. Case A shows a very well calibrated and adjusted machine that places electronic components on a printed circuit board with high repeatability. Case C shows high scatter and misalignment, which is an indication of poor calibration or poor maintenance of the machine. This results in a lot of scrap parts, as can be seen in the photo below. Overproduction. Overproduction is the manufacture of an article before it is actually needed. Overproduction is very costly for a production facility as it prevents the smooth flow of materials and affects quality and productivity. The Toyota production system is also known as just-in-time, JIT, because each part is manufactured exactly as needed. The overproduction is called just-in-case. This leads to excessive throughput times and high storage costs and makes fault detection more difficult. The simple solution for overproduction is to stop the flow of material. This requires a lot of courage, because the problems hidden by overproduction are revealed. The concept is to plan and produce only what can be sold and delivered immediately. Problem: setup times for frequent product changes. Solution: optimization, reduction of setup processes. Waiting time. Whenever parts do not move or are processed, there is a waste of waiting, idle time. Typically, more than 90% of the production time in traditional series and batch production is spent waiting for processing. A large part of the throughput time of a part is associated with waiting for the next operation. This is usually due to this. The material flow is poor. Production runs, lots, batches, are too long. The distances between the workplaces are too large. A minute lost in a bottleneck process is a minute lost in the entire production of the factory that can never be recovered. Linking processes so that one flows directly into the other without intermediate buffers can drastically reduce waiting times. Transportation. Transporting products between processes is a cost factor that does not add value to the product. The drawing shows an example of the path of a product through production. The blue dots represent individual workstations. As can be seen, there is no clearly structured and short path through production here. This is a problem. It often arises from the fact that over the years new products are added to a factory, which are subject to different work processes than the previous ones. This makes it important to look at the layout of the factory every 1 or 2 years and, if necessary, adapt it to the current production. Excessive movement and handling cause damage and are a danger to quality. Technical aids for transport increase costs. Inventory. Work in progress is a direct result of overproduction and waiting times. As you can easily see from the photos, very large stocks of material were procured here. The incoming warehouse was not large enough to accommodate all this stock. Therefore, the goods had to be stored outside at the truck docks. The material is exposed to wind and weather and can be damaged as a result. Such overstocks are almost always a sign that production is not working according to the pull principle. Overstocks tend to hide production problems that need to be identified and resolved to improve operational performance. Excess inventory increases throughput times, consumes production floor space, delays problem identification, and hampers communication. Motion. Unergonomic workplace design that causes increased bending, stretching, walking, lifting and gripping. This leads to health and safety problems. Jobs with excessive movement should be analyzed and redesigned with the involvement of plant personnel. But also overstocks in the warehouse can cause extra motion. As you can see in the picture, pallets may have to be removed first if you want to get access to stored material on the shelf. Extra processing. Often referred to as cracking a nut with a sledgehammer. Many companies use expensive high-precision equipment where simpler tools would suffice. This often leads to a bad plant layout, since pre- or post-operation are far apart. From an economic point of view, a high plant utilization of these machines or devices is often required, which leads to overproduction in order to cover the high costs of these plants. Toyota is known for the use of cost-effective automation, combined with perfectly maintained, often older machines. Investments in smaller, more flexible equipment wherever possible, the creation of manufacturing cells and the right combination of process steps significantly reduce waste. Over-engineering is a form of extra processing. Here is an example that you definitely know. Microsoft Excel comes with a large number of built-in functions, of which the average user uses only a very small percentage. All other functions have to be purchased even though they are not needed. The same is true for other Microsoft products such as Word or PowerPoint. This is extra processing and a form of mudah, because it doesn't create value. Now we have learned the 7 W's of waste. The +1 what consists in the non-application of knowledge and skills that employees possess. This knowledge and skill is often underestimated by managers. Ask your employees for their experience and opinion. Therein lies a treasure trove of knowledge. Now that we've learned about the 7+1 types of waste, let's turn our attention to the 5S. Does this look familiar to you? Would you like to have it more like this? Then 5S is the way how to do it. 5S is a methodology to organize your workplace. All 5S principles can be applied to your desk, to your workbench, but also to your computer desktop. It is simple but very powerful. It consists of 5 steps. The first step is called seri, which is Japanese and means sorting. Here you first sort all things according to how often you use them. The second step is called seitan and means arranging the work equipment so that it can be reached easily. Step 3 is seizo, which simply means clean up. In step 4, seiketsu, you make it a habit. And in step 5, shitsuke, you make sure you don't lose your new habit again. Let's start with seri, sorting. Here you first sort all things according to when and how often you use them. The same rules apply to your computer desktop and to your physical desk. On your desktop is only what you are working on today. On your desk is only what you are working on today. Desktop, things to do in the next 2 weeks are stored in folders and are shortcut as favorites in your file manager. Desk, things to do in the next 2 weeks are stored in file covers in the desk drawers. Things that are longer out, for example that should be worked on in the next 6 months. Desktop, Things are stored in a structured folder system on your computer hash. Desk, things are stored in folders in a filing cabinet. Most important, things that you haven't touched for a year, archive them somewhere or, better, throw them away. It is very unlikely that you will seriously work on it. That was the first step, Seri. The second step is called Seitan and means arranging the work equipment so that it can be reached easily. For a right-handed person, for example, this would mean placing the phone or the notepad on the right side of the desk, slightly back from the keyboard. For your desktop, it could mean that you arrange files and folders according to their subject. Now we have covered step 2, Seitan. So let's move on to step 3, Seizo. Seizo simply means cleaning. Make sure you always have a clean workplace. Working is more convenient when your workplace is shiny. Now we have covered step 3, Seizo. So let's move on to step 4, Shiketsu. Shiketsu simply means that you make this a standard. Do this for a week. Find out what works well for you and what doesn't. Keep what works well for you. Improve what can be improved. Now we have covered step 4, Shiketsu. So let's move on to step 5, Shitsuke. Shitsuke just means sustain, keep doing it. Make yourself a fixed appointment once a week. Do the 5S at this appointment. At your desk. At your desktop. And if you want, even in your private kitchen. Make it a habit. Congratulations! You have now completed your first 5S routine. If you want, do this transfer exercise. Team up with a colleague, a partner or a friend. Do a first iteration of 5S at your desks, Seri, Seitan, Seizo. The desk owner performs the work, the teammate coaches. After finishing the first round, continue at the teammate's desk in changed roles. 30 minutes for each desk. Repeat the task in a week from today and complete the circle by performing Shiketsu and Shitsuke. With that, we have successfully completed the third chapter in this module. Please take a moment and think about what your 3 key learnings were in this chapter. Write them down. Ask yourself if you can use these lessons learned in your daily work. And if so, how? Now reward yourself and take a short break.